Hello again, it's Sean and I'm going to talk you through practice set 2, paper 1 of AQA's non-calculator paper. So I'll just get straight into it this time, but feel free to skip on to questions you're struggling with rather than sitting through questions you know how to do, if you prefer. So, first question, we have to circle the number that's not a multiple of 6. And so, first of all, you need to remember that multiple of 6 just means a number in the 6 times table. So if it's not in the 6 times table, it's not a multiple of 6. So the slow but sure way of doing this would be to just know your 6 times table, which goes 6, 12, 18, 24, 30. So we can see already that 24 is in there. And so the answer is not going to be 24 because that definitely is in the 6 times table. So carry on from 30. Get 36, 42, 48, 54, 60. 60 is 6 times 10. Keep going, add another 6, get 66, 72, 78. So you can keep going on if you wanted, but if you notice, we've skipped over 76. 76 doesn't appear in the 6 times table, so for that reason, 76 is the one that isn't a multiple of 6. And so we can circle 76. Another way of doing question 1 would be to think, which of these numbers doesn't divide by 6 without any remainder? The one that divides by 6 and leaves a remainder is 76. All the others divide by 6 exactly. Either way round, 76 is the answer we need to circle. Question 2. Which symbol makes this statement correct? So we've got two numbers, 0.062 and 0.52. And so, which of those numbers is the biggest? Well, if we round off the numbers to 2 decimal places, it looks like money. And money is something we use most days, so that'll make it easier. So 0.06 is roughly 0.062 is roughly 0.06. So that's about 6p to the nearest penny, that would be. Whereas this one, 0.52, in terms of money, would obviously be 52 pence. If you just imagine an invisible pound sign at the beginning. Now, with these inequality symbols, the open mouth faces the bigger thing. If you imagine it like a crocodile, the crocodile, which is always greedy and hungry, will always want to eat the bigger meal. So the open mouth will face the bigger thing. And so obviously these two values aren't equal, so it's not going to be that one. 6p isn't the same as 52p. Hopefully you'll know that 52p is definitely bigger than 6p. And so the crocodile would prefer to have 52 pence than 6 pence, because 52 pence is bigger. And so the correct symbol that would go inside here, in the middle of them, would be this symbol, with the open mouth pointing towards the bigger thing. So we need to circle this one. Question 3, we've got a one-step equation to solve here. X minus 7 equals 56. So an equation's only solved when we've worked out what the unknown thing is worth. So we want to get to the point where it's x equals whatever. So one way we can think of this is we need to get rid of that 7, which is a minus. And what we can do is we can move it to the other side of the equation. But when we swap side, we swap sign. Opposite of minus is plus, and so the minus changes to a positive. On the other side, we'll get 56 plus 7, which will be 63. And so the answer to this equation is x must be 63. Another way you could think it through would be just which number fits here to make it work. Is 8 take away 7 56? No. Is 49 take away 7 56? No. Is 56 take away 7? 56? Nope. The only number that would work for x is 63, because 63 take away 7 equals 56. And so what you could do is just substitute in different values into this equation and see which one works. And the only one that works is when x is worth 63. So that's, again, another way why we'd be circling x equals 63. Question 4, we have to circle the expression that can be written as 2y squared. Now, with algebra, if we've got different things next to each other, in this case the 2 and the y, with no instruction between them, we can always assume there's an invisible multiplication sign. So 2y squared is the same as 2 multiplied by y squared. And y squared itself means y multiplied by y. If something is to the power 2, it means we're multiplying it by itself twice. And so 2y squared equals 2 multiplied by y squared, which in turn equals 2 multiply y multiply by y. And so for question 4, the correct one to circle would be this one here. We're not squaring the 2, we're only squaring the y squared. So at this stage here, if you remember BIDMAS, what we'd need to do is to do the power first. So first of all we do the power, which just relates to the y squared. And then we could simplify it down if we wanted. And so that's why it's not 2 squared and y squared, it's just for y squared, which is y multiplied by y. So the 2 doesn't become 4, or 2 times 2. Question 5, we have a bar chart and we want to change it into a pictogram. So what we've been given already is a key, where each complete circle represents 2 students. And so what I've got here is symbols of my own. So if a full circle is 2 students, then half a circle will obviously just be 1 student. So the bus means that 8 people took the bus. So if each circle represents 2 students, what we need for this one is 2, 4, 6, and 8. We need 4 circles in the row for the bus. The car is 7. So to represent 7, we need 3 circles. 2, 4, 6. And that extra 1 student will be represented by half a circle. So that's where the half a circle comes in. The train, only 1 student took the train, so we need half a circle to represent that student. And walking, we had 4 students. So 1 circle is 2 students, another second circle, 2 plus 2, for 4 students. And so that's a pictogram representation of this bar chart on the left-hand side. And that's all we need to do for question 5. Question 6, we have to work out a fraction of an amount, in this case 3/5 of 200. And so there's a couple of ways we can do this. I think the first way I'd suggest would be to work out what 1/5 of 200 is. And we can do that by first of all just dividing 200 by 5. So for that we can use a trusted bus stop method. And then we can ask how many 5s fit into 2. So the answer is 5 is too big to fit inside 2, so the answer is 0. And so we still have this 2 left over, which therefore is a remainder. Now 5s into 20 goes 4 times, and goes 4 times exactly with no remainder. And finally 5s into 0 is 0. And so, therefore, 1/5 of 200 is 40. But we don't want to work out what just 1/5 is, we want 3/5. And so using this method, we work out 1/5 and then think, well, how many fifths do we need? And so we can picture it like this. I'm just going to get a diagram to show you how it works. And so if you remember at school, maybe splitting circles into different amounts, this is the same idea. So what we're going to do first is just divide this circle into 5 pieces, just to help you picture what's going on. So we worked out 1/5, which is 1 slice out of a 5 of a circle. So 1/5 is 40. But we want 3/5. So once you worked out what 1/5 is, 3/5 will be the 1/5 we've worked out, which is 40, multiplied by 3. 4 times 3 is 12. Add on the 0, gives us 0. And so 3/5 of 200 is 120. So just to picture that, 3/5 is 3 pieces out of a total of 5. If 1/5 is 40, we want 3 lots of that 40. I'm not going to mention another way which we can use. I think this second way is a bit longer and a bit more complicated, but just in case it appeals to you, I'm going to mention it. So the second way I'm just going to briefly mention is to remind you of how we can multiply fractions together. Now to work out 3/5 of 200, we can multiply 3/5 by 200. I'm going to show you how you can do it on a calculator. I know you're probably thinking, but it's not a calculator paper, but just bear with me. I'm just going to show you how the of works as a multiply. You see we get 120. So what good is that if we don't have a calculator? Well, I'm just showing you that we can multiply one fraction by an amount to get the answer we need. But if we're multiplying a fraction by a number that isn't a fraction, what we'd need to do is change the second number into a fraction as well. And any whole number can be changed into a fraction by just writing it all over 1. 200 is exactly the same as 200 over 1, because 200 divided by 1 is still 200. Now we've done that, we can just multiply the top by the top and the bottom by the bottom. So 3 times 200 gives us 600. 5 multiplied by 1 gives us 5. Now that we've got 600 over 5, we can then just treat this as a division by doing 5 divided by 600. So 5s into 6 we can fit 1 with 1 left over. 5s into 10 now we can fit 2 exactly. 2 5s are 10, so we've got nothing left over. And finally 5s into 0 goes 0 times. And so 3/5 of 200 using this method again would give us 120. 6b, work out 25.8 plus 12.6 divided by 2. So we've got 2 different operations, and so what I'm going to remind you of first of all is BIDMAS. Brackets, indices, which is a fancy word for powers, division, multiplication, addition, and subtraction. And so in this list, we have a look what we've got. We've got we haven't got a multiplication. Can't seem to see. That's a addition. So we've got adding to do. You've also got a division symbol. So we've got some dividing to do too. And so in the BIDMAS list, division comes before addition. We divide and multiply before we add and subtract. And so what we need to do here is leave alone the addition for now and just focus in on what 12.6 divided by 2 is. And so again, division, what we can do is use this bus stop method. 12.6 divided by 2. Anything we do if it's a decimal division is we include a decimal in the number as we need and make sure we've got a decimal lining up at the top and the bottom of a bus stop. Apart from that, we treat it as any other number. And so 2's into 1 we can't fit, and so that 1 is still left over. 2's into 12 we can fit 6 times exactly. 6 2's are 12, nothing left over. And finally, 2's into 6 we can fit 3 times. And so 12.6 divided by 2 gives us 6.3. Well, now we've divided, the only thing left to do is just to add these numbers up. And so, if we just line them up nicely with the decimals in line, eight plus 3 would give us 11. Make sure the dots line up top and bottom. And because this gives us 11, we need to carry 1 along. Now we've got 1 plus 5, which is 6, plus the other 6, which gives us 12. So put the 2 down, carry another 1 over. And finally 1 plus 2 gives us 3. So the final piece of the puzzle is to add the numbers together and we get 32.1. That's our final answer. So on the answer line for question 6, part B, we need to put 32.1. And that's question 6 done. Question 7, we need to simplify some algebra. So we've got 7a plus 5b plus 3a minus 2b. And we need to think about how many different things we've got to group together. The answer here, we've got 2 different things. We've got a's. Always have a look at the sign in front of the thing we're dealing with. So if that's 7a, because it's got no sign in front, we can assume it's positive. These 3a's have got a plus in front, and so we treat these 3a's as positive. So one thing we've got is a's. The other thing we have is b's. So we need to group these together. So just thinking about the a's, we've got 7a plus 3a, which gives us 10a. Now for b's, we've got 5b. Over here, we've got a minus. So this 2b we treat as a minus. So 5b minus 2b would give us 3b. And so what we need to do next is to piece these 2 things together to give us our final answer. So final answer, we've got 10a minus, 10a plus 3b, because this 3b is minus. 5b minus 2b, we still have positive 3b. So we have 10a plus 3b, and that's our final answer that we can put down on the answer line. And that's all we need to do really for question 7. 10a plus 3b. Question 8. We've got a ratio question sort of mixed in with a fraction one as well. So it's about a bag which contains red counters and blue counters in a particular ratio. So we've got 3 lots of red counters for every 5 lots of blue. Because red's mentioned first, the first number relates to the red, and blue is mentioned second, and so the second number relates to the blue. So we can think of this in terms of 3 lots of red and also 5 lots of blue. So in total there's 8 different lots of counters. 3 plus 5 gives us 8 different parts. And so what I've done here is given a diagram to illustrate how you can think of this. Three lots of red, 5 lots of blue. So in total there's 8 different lots of counters. The fraction which are red would be 3 bits out of a total of 8, because 3 plus 5 is 8. And so the one we need to circle for question 8 is 3 out of 8. 3/8 of these counters are red. Question 9 is about a number machine, and we need to work out the output when the input is 12. And so the input is given by x, and so in this case we're saying that the input, which is x, is now 12. And so what we can do is just follow the instructions of the number machine. So the input goes in, which is 12. The first thing we need to do is multiply by 5. So 12 multiplied by 5, you should find that's 60. And the next step is to take away 3, and once we've done that, that'll give us what the output is. And the output is called y. Anyway, 60 minus 3 would give us 57. And so when the input is 12, the output of 57 pops out. So the answer is 57. Part B, we have the same number machine, and we need to work out the input now when the output's 27. And so this time around we're starting off with the output. So if the output is 27, that means that 27's come out. And so what we need to do is start over here and work backwards. And so we start with the output, which is 27, we've been told. But this time we go the opposite way, and because we're going the opposite way, we're doing the opposite things. So we work back on ourselves and rewind it to the beginning. So going forwards, at this stage above, we subtracted 3. But because we're going the opposite way, we're now going to do the opposite thing. Opposite of subtracting 3 is to add 3. And so 27 add 3 would give us 30. But we carry on working backwards. So the next stage, we look above. Going the forwards way, from left to right, we were multiplying by 5. But now we're working backwards, going from right to left, we're going to do the opposite thing. And the opposite of timesing is to divide by 5. And once you've done that, we'll have our input worked out. And so 30 divided by 5 would be 6. And so the initial input must have been 6. And so for this one, the input is 6. Let's double check. 6 times 5 is 30, minus 3 is 27. You could do this using a trial and error approach, but I think the easiest way might be just to reverse the number machine and get back to the beginning. Finally, for part C, we're asked to write down what y is as an expression in terms of x. And so what I'm going to do here is just show you step by step what happens to x. So we need to keep it in terms of algebra. We're not given any numbers for y and x, so keep it in terms of algebra. Let's have a look what happens. So we start with x. The first step is it gets multiplied by 5. So x multiplied by 5 gives us 5x. 5 times x we write as 5x. We then minus 3, and so if we had 5x at this point, we just knock off 3, that would give us 5x minus 3. And so what comes out in terms of x is 5x minus 3, but because this is being called y, we can say that y equals 5x minus 3. And so to write y as an expression in terms of x, an expression, strictly speaking, doesn't need an equals sign. But if you want to, you can put 1 in this case. So you can put y equals, if you'd like, 5x minus 3. Y is 5 lots of x, then take away 3 from that. And that's question 9 done. Question 10 is about a quiz. So teams are asked 20 questions, and we've got a breakdown for how points are scored. And so we're told that 3 points are scored for each correct answer given. So I'll just highlight this, or underline it in green. 0 points are scored if a question's not attempted. So I'll just highlight, well, underline this in blue. And finally, if you get a question wrong, 2 points are taken away. So minus 2 points for an incorrect answer. So we need to work out the total number of points that Team A scores. So as long as we stick to what we know, this won't be too bad. And so 3 points for each correct answer. So correct, we've got 12 questions. And so for the correct questions, we've got 12 times 3 points 1, which will be 36 points. If one's not attempted, if you're not attempting a question, you get 0 marks. So not attempted doesn't really matter in terms of a point total. So you could say it's even 5 times 0, which is just 0. Not worth considering, as I say. And finally, 2 points for an incorrect answer. We can work out how many points are taken away. And so for the incorrect answers, they gave 3 which were incorrect. And so 3 times minus 2 is what we need to work out. 3 times 2 would be 6. So 3 times minus 2 would be minus 6. So from this we can work it out. So for the correct answers, we've got 36 points. Minus 6 for the incorrect ones. So 36 minus 6 gives us 30. I don't know if I wrote 0. That is just mad. What is my brain doing? Never mind. 36 take away 6, we've got 30. And so the total points for these 20 questions is 30. Part B. Got the same quiz, and now a different team. So Team B answers 16 out of 20 questions correctly. And we need to work this out as a percentage. And so 16 out of 20, how we read it is how we put it into the fraction. So 16 is mentioned first. The number that comes after the of is 20. Whatever comes after of or out of goes on the bottom of the fraction. And so 16 out of 20 would be written like that. 16 on top, 20 on the bottom. Now there's a few ways we could do this. What I'd suggest doing is just remembering that a percentage means a fraction out of 100. So that's what a definition of percentage is really. It means out of 100. So at the minute we've got a fraction which is out of 20. We want it to become a fraction out of 100. And so what could I do to 20 to get it to be 100? What could I multiply 20 by to get it to become 100? Well, how many 20s fit into 100? 20, 40, 60, 80, 100. 5 20s fit into 100, and so what we could do is multiply the bottom number by 5. if we do that to the bottom number, we need to do the same to the top number. So we need to do 16 multiplied by 5. Just to refresh your multiplication, we can do it like this if you wanted. So 5 times 6 would be 30. So carry on the 3. Now we need to do 5 times 1, which is 5. 5 times 1 is 5, plus the 3 we've just carried is 80. And so we'd get 80 out of 100, which would mean by its definition 80%. And so 80% is the answer we need to put down for 10B. Now 10C is a bit more awkward, but still not impossible. This is like a mystery. So we're told that after 17 questions, Team C has 35 points. But after 20 questions, Team C's got 34 points. So how many of the last 3 questions are answered correctly, not attempted, or answered incorrectly? And so after 17 questions, they had 35 points. After 20 questions, we must have answered another 3 questions. Question 18, 19, and 20. So they end up with 34 points, and so overall on the way they've lost 1. But if I just remind you here, you can't lose 1 on its own. You either get 3 for a correct answer, or nothing if you don't attempt it. And so how can we make a total of -1, because we've lost 1 point, from 3 and a 2? So let's just think. What we could have is -2 twice and 3 once. And so question 18 might have been answered correctly, in which case it'd take us to 38 points. Because it answered correctly. Then from 18 to 19, maybe that was answered incorrectly. If you answer a question incorrectly, you lose 2 points. And to go from 36 to 34, if you answered this next question incorrectly, that'd lose another 2 points. And so what it could be is that one question was answered correctly, this one here, question 17, but question 18 and question 19 were answered incorrectly. And using this idea, all the questions would have been attempted, 2 wrong and 1 right, so no questions were left blank. And so 1, 0 and 2. Now, quite a tricky question I suppose, but one way you could do it as well would be to consider it like this, as a trial and error question. And so question 17 might have been 35. Question 18, maybe that was answered right, maybe 19 was answered right, and maybe question 20 was answered wrong. If 2 are answered right, that would be 38 points and 41 points. Then take away 2 for a wrong answer, and be 39. So just by doing a trial and error approach, we could see what would work. So maybe 1 was right, 1 was left blank, 1 was wrong. Obviously it seems silly me doing it now because you know what the answer is, but I'm just showing you how you might have tackled it instead. So 35 plus 3 would be 38. If that's left blank, that wouldn't change. Then -2 would be 36. Anyway, eventually what you'd get is that the only way it would work is if 1 question was answered incorrectly, then 2 questions were answered correctly. That's the only way you could take your score from being whoopsie-daisy, making mistakes all over the shop today. I mean, if 2 were answered incorrectly, and only 1 was answered correctly, that's the only way we could do it so that the total score would end up as 34. That's the only way it could happen. So for question 10, part C, 1, 0 and 2 is what we need to put on our answer line. Question 11, we've got a sequence of patterns that uses black squares and white squares, and for part A we need to circle the expression for the number of black squares in pattern N. So for this one, what I'd suggest doing is just a rough table. Oops, let's get the right pen. So if we just think of a pattern number, a number of black squares by the side of it, and see if we can spot a pattern ourselves. Pattern number, a number of black squares. So we've been given the first three patterns, pattern 1, pattern 2, and pattern 3. So let's just have a look at the black squares for these patterns. First one's got 4 black squares. The second pattern has 1, 2, 3, 4, 5, 6 black squares. And the third pattern has got 1, 2, 3, 4, 5, 6, 7, 8 black squares. And so the number of black squares is increasing by 2 each time. So for example, the fourth one would have 10 black squares. So let's have a look at this sequence here. 4, 6, 8, 10. This sequence is increasing by 2 each time. So the sequence is going up in 2s. 6 plus 2 is 8. 8 plus 2 is 10. Because the sequence is going up in 2s, the nth term for this sequence would have a 2 in front of it. If it's going up in 2s, it will relate to 2n. Get up in 2s, so a 2 needs to go in front of the n. So already we can see that it's going to have to be this one. But I'll explain where this plus 2 comes from. After you realise it's gone up in 2s, what you need to do is compare the sequence you've got to the main sequence you taught from primary school, which goes up in 2s. So what sequence have you been taught for ages that goes up in 2s? Answer is the 2 times table. So if you compare this to the 2 times table, which is 2, 4, 6, and 8, compare the 2 times table to what the sequence actually is. So the sequence you've got here, for each value of a 2 times table, the sequence we've got for the black squares is going to be 2 higher each time. 2 add 2 is 4, 4 add 2 is 6, and so on. So it's going up in 2s, but each number in the sequence is 2 higher than the 2 times table, so it's 2n plus 2. So that's where the plus 2 comes into it, which is why you end up with a plus 2 at the end. So the one we need to circle is 2n plus 2. Part B. Will the number of black squares always be even? Well, if we have a look at the sequence we worked out in Part A just to remind us, the number of black squares goes 4, 6, 8, 10. So the next one will be 12, 14 and 16. The answer is yes, it's always going to be even. So a reason, you could give several different worded explanations, but I would suggest something along the lines of that the sequence begins with an even number and increases by 2 each time. And because 2 is also even, the total number of squares will always end up being an even number. The total number of black squares, I mean. Question 12. Question 12. 82 children visit a sports centre. 50 of the children swim. At least one adult is needed for every 12 children who swim. And so if we have this in some sort of table, for example, swimming children and adults needed, then we can build it up to how many adults would be needed for 50 children. And so what we're told here is that one adult is needed for every 12 children who swim. And so if we had one adult could look after 12 children. So is one adult enough? Obviously not. If one adult can look after 12, then two adults, a second adult, could look after another 12. 12 plus 12 would be 24. That's still not enough adults. So let's go again. Bit of a wonky line there, I'll just try and correct that. There we go. Oh, that'll do. Add in a third adult. A third adult could look after another 12 children. So 12, 24, 36. We're getting closer, but we're still not there. Now a fourth adult could look after a further 12 children, which would be 48. So it's tempting to maybe say, well, 4 adults would be enough, but strictly speaking, 4 adults isn't quite enough. 4 adults could only look after 48 children, so these extra 2 children need an extra adult, really. And so what you'd need is an extra 5th adult, which could look after up to 60 children. So you need a number which is at least good enough for 50 children, and the smallest number of adults that can look after at least 50 children would be 5. So for the swimmers, these 50 children need 5 adults. And we can have a similar approach for the dancing children. So again, it says here for dancing children, for 32 of them dance, and 1 adult is needed for every 15 children who dance. And so 1 adult could look after up to 15 dancing children, and just build it up in the same way as for the swimming children. 2 adults could look after 30 dancing children. So we're nearly there, but still not quite enough adults, because between them, 2 adults, 32 children, that'd be 16 children per adult. But 1 adult can only look after 15 children. So you actually need a 3rd adult in there. So a 3rd adult would be able to look up to 45 children. So 3 adults could look after up to 45 children, which would be enough. And so for the dancing children, we need 3 adults. And so combining these 2 tables we've got here, the swimming and the dancing, we can just combine what we've got here to work out what's needed. So we need 5 adults for the children that are swimming, and we need an extra 3 adults for the children that are dancing. And 5 plus 3 would give us a total of 8 adults altogether. So 8 adults in total are needed. So that's our final answer for question 12, 8 adults. Question 13 involves a triangle, and we need to work out the value of x in this triangle. So what we need to do first of all is to just acknowledge the size of each angle in the triangle. So we have a square here which denotes a right angle, so that's 90 degrees. The other angle is 4x, and the third angle in the opposite corner is 2x. And so what you need to know for this problem is that the total of all the angles inside any triangle is 180 degrees. And so these three angles here, the 90 degree one, which is a right angle, plus 4x plus 2x will all add up to 180. Because angles in a triangle will always add up to 180 degrees in total. So 90 degrees is a right angle, that's 4x, and the other one was 2x. And so what we can do is we can simplify the left-hand side of this equation. So we've got 90, obviously, but 4x plus 2x in total gives us 6x's. And that equals 180. And so now we just need to solve this equation and work out what x is. So this 90 over here is a positive thing. And so if we move this 90 to the other side, if we swap it to the other side, we'll swap its sign. Opposite of positive 90 is minus 90. What we're doing really is just taking away 90 from both sides, but I often think of it as swap for side, swap for sign. So after moving that 90, we'd only have 6x left on the left-hand side of the equation. And over on this side, 180 take away 90 would leave us with just 90 left. And the same way as before, what's that 6 doing to the x? Well, the 6 is multiplying the x. If you've got two things in algebra just next to each other, it always means one is multiplying the other. And so because that 6 is multiplying, when we move it over, it'll change to the opposite sign. Opposite of multiplying is dividing. And so x will be 90 divided by 6. So we can do this over here using the trusty bus stop method. How many 6's fit into 9 first of all? 6 can fit into 9 once. 1 6 is 6, which is still 3 off 9, so the remainder is 3. And then how many 6's fit into 30? That would be 15. So 90 divided by 6 is 15, and that's what x is equal to. So the value of x, 15 degrees. Question 14, we're told about the sum of two square numbers is 180, and we need to work out what those two square numbers are. First of all, what we need to do is remind ourselves what square number means. So square numbers are numbers we get when we multiply whole numbers by themselves. So the first square number is 1, because it's 1 multiplied by 1. The next square number is 4, because that's 2 multiplied by 2. The next one is 3 times 3, 4 times 4, 5 times 5, and so on. And to be honest, you should know these off by heart ideally, all the way up to 12 squared, which is 12 times 12. So 1, 4, 9, 16, 5 times 5 is 25, 6 times 6, 36, 7 squared is 49, 8 squared, 64, 9 squared is 81, 10 squared, 10 times 10 is 100, 11 times 11 is 121, and 12 times 12, 12 squared, is 144. And so for square numbers, are just these numbers I wrote here. And so what we need to do is to find two numbers from this list, if we can, that add up to 180. Sum means added up. So let's see if we can spot these numbers. So 180, we need to think of looking on the big side, because 180 is quite a big total. And what you should be able to spot is, eventually, that 36 and 144 work. You can do this by trial and error, just trying different combinations of square numbers until you get two that add up to the right thing. But 144 plus 36 does add up to 180. And so the two square numbers we need are 36 and the second one is 144. Part B of question 14. Kim says the sum of any two different square numbers is always even. Is she correct? We need to write down a calculation to support the answer. And so I just quickly copy down the square numbers we had from part A, or just in fact a selection of that list. We can think of adding up two different ones and seeing if the answer is always even. Sometimes it will be. For example, 4 plus 16 is 20, which is even. But if we have a look at the first two next to each other, for example, 1 plus 4, well, 1 plus 4 gives us 5. 1 plus 4, 1 squared plus 2 squared equals 5, which is odd. And by odd, obviously, we mean not even. So we've just found one example out of many, many examples that show that Kim isn't correct. The sum of any two different square numbers might be even, but it isn't always even. So, is she correct? That's a valid reason, because we found a calculation which shows her to be wrong. So final answer is no, she is not correct. Question 15, we've got musical competitions, a piano competition and a violin competition. So we're told that both competitions took place in 2009. And which year did the violin competition take place? So the violin competition takes place every 4 years. So if we just think of the violin competition for now. So it took place in 2009. And because it takes place every 4 years, the previous time it took place will have been 2005, just by counting 4 years back. But if you count another 4 years back from 2005, 2005 take away another 4 years would be 2001. Go back again another 4 years. 4 years before 2001 will be the year 1997. And finally, if we go back another 4 years, 4 years before 1997 will be 1993, which is in the list. And so which year did the violin competition take place? It was 1993. So if one we need to circle is 1993. Part B, we need to find out when the next year after 2009 is that both competitions take place. So if we just compare the piano and violin, they both took place in 2009, we're told. But the piano competition takes place every 3 years, and so the next time the piano competition takes place after 2009 will be 3 years on from that, which is 2012. 3 years on from 2012 is 2015, and so on. So because the piano competition takes place every 3 years, these years will be going up in 3 each time. 3 years after 2015 is 2018, and so on. But because the violin competition takes place every 4 years, for the violin, the next time it will take place will be 2013. 2009 plus 4 is 2013. Add another 4, that'd be 2017. Add another 4, it'd be 2021. Now let the piano catch up. Add another 3 to the piano. 2018 plus an extra 3 years will be 2021. And so what we've found is that 2021 appears in both lists. And so that'll be the year, the next year, that the piano and violin competitions will both take place in the same year. So it's effectively a common multiple question. That was going to be 2021. In part C, we're told in any leap year, if a number made by the last 2 digits is divisible by 4. So for example, 1996 and 2004 were leap years because 96 and 04 are both divisible by 4. Give a reason why the violin competition will never take place in a leap year. Well, the violin competition took place in 2009, then it'll next take place in 2013, 2017, just copying down what we did from part B. But if you notice these numbers, all of these years are odd. But if a number is divisible by 4, it means it has to be even. And so that's the shortest way I can think of explaining why the violin competition will never take place in a leap year. For it to take place in a leap year, the year of the competition would need to be an even number, to say the least. But the violin competition will always be on an odd number of years. So that's probably the easiest way of putting it. The violin competition only takes place in years that are odd numbers. And so that's why the violin competition could never take place in a leap year. Question 16, we've got some algebraic substitution to do here. So we need to work out the value of 4 brackets 2x plus 3y when x equals 8 and y equals minus 3. I'm going to show you how to do this in 2 different ways, in fact. And so one way I'm going to show you is by expanding the brackets. Expand the brackets first. As a general rule, it's never normally a bad idea to expand brackets for foundation. And so if we were to do that, to expand brackets just means to multiply them out. And so 4 multiplied by 2x would give us 8x. Plus sign, so put a plus sign on. And then 4 multiplied by 3y would give us 12y. Now we need to think about what x actually is and what y actually is. So x, we've been told to use a value of 8. And y, we're told, is minus 3. And so what we're going to do now is just substitute in these values for x and y. And so if x is 8, 8x just means 8 multiplied by 8. And then 12y means 12 multiplied by minus 3, because we're told to use y as minus 3. So according to BIDMAS, if you've got multiplication and addition, you'd have to multiply first before we add. And so we're going to work out 8 multiplied by 8 and 12 multiplied by minus 3 before we add them together. 8 times 8 gives us 64. And 12 multiplied by 3 is 36. But because it's a minus 3, that would give us minus 36. So now what we need to do is 64 plus 36. Only thing here is, it's not a normal 36, it's minus 36. If the two signs next to each other are plus and minus, if they're mixed, mixed makes minus. So for example, if you're adding a negative number or subtracting a positive number, that works as just doing a subtraction. And so that would be 64 minus 36, which we can do over here if we need. 4 take away 6 we can't do, so we can borrow one from the 6, which makes it 5. The one we've borrowed, we move along. So that 4 is now 14. 14 take away 6 is 8, and 5 take away 3 is 2. So the answer is 28. Another way we could have done this question was by not expanding the brackets first. So we could have expanded the brackets last. So it doesn't matter which way you do it. I'd suggest expanding the brackets first, just get them out of the way. But just to show you how this would work if you wanted to expand them last, I'll show you why it works. So in this case, leaving the brackets as they are, we can say that x is 8, because it says x is 8. And so leaving the brackets intact, 2x means 2 multiplied by 8, and 3y, because y is minus 3, that will mean 3 multiplied by minus 3. So working out the brackets, again, within the brackets we've got a multiplication to do, 2 multiplications to do in fact, and an addition. So we need to multiply first before we add the things together. And so 2 times 8 is 16, plus, and then 3 times minus 3, well 3 times 3 is 9, because this is a minus 3, that gives us minus 9. Now if we're adding a minus, as I mentioned before, it works as just subtracting. If you plus a minus, or minus a plus, it works as just doing a normal subtraction. So if the two signs next to each other are different, a plus and a minus or a minus and a plus, we can just replace the two symbols next to each other with a minus sign. If the two symbols next to each other, by the way, were both the same, minus and a minus makes a plus, or a plus and a plus again makes a plus. When the signs are the same, replace them with a plus. When the signs are different, replace it with a minus. So now, in the brackets, we've got 16 take away 9, which is 7. And the final step is just to do 4 multiplied by 7. Expand them out last, take what's on the outside and multiply it by what's on the inside. We'd have 4 multiplied by 7, which of course would give us 28. So doing it this way, we'd still get that this expression here equals 28. And so that's question 16 done. Question 17, we're asked to factorise 15x plus 35y minus 40z. Now sometimes in Maths GCSE Foundation you have to factorise something of the type where it's, for example, x squared plus 5x plus 6. We've got three different things. So it's possible to confuse this one here for one of those, but that would be wrong. If it's a quadratic, and by quadratic I mean something with a squared thing in, and then the same letter following, and then maybe a number at the end, that would go into two brackets. But here, because there's no squared things, no squared letters, this would actually still just be one bracket. And so what we have to do here is just think of this in terms of what number can we fit into 15, 35 and 40. What's the biggest number that divides into all of these? And the answer would be 5, because each of these numbers is in the 5 times table. So we've got 5 now. What do we multiply 5 by to get 15? We'd have to multiply 5 by 3, and because we need 15x, we need to include an x here. In the same way, we need to multiply 5 by 7 to get 35. But it's not just 35, it's 35y. So we need to include a y at the end. Then we have a minus sign, so put in a minus sign. Then 5 to 40, we need to multiply 5 by 8 to get 40. But once again, it's not just 40, it's 40z. And so we need to include a z at the end of the 8. And that's fully factorised now, and that's the final answer. Question 18. Joanne has a fair 5-sided spinner. Fair means that each side of it will have an equal chance of being landed on. So what we need to work out here is the probability of scoring a 4 with one spin. So we can have a look at this spinner now and just see how many 4s do we see on it. Well, obviously there's only one 4 on the entire spinner, but how many sides does it have? It's got 1, 2, 3, 4, 5 different sides. And so we can say that 1 out of the 5 sides is a 4. And so because 1 out of 5 sides is a 4, the chance of it landing on a 4 is just 1 out of 5. Because there's only one way of landing on a 4 out of 5 possible sides it could land on. And so the answer to this one's 1 out of 5. Part B is a bit harder. What we need to do for part B is to work out the probability of scoring a 4, but this time we're talking about 2 different spins. And so the best way to consider this one, I'd suggest, would be to do a probability space diagram and think of it as a table. Your first spin combined with the second spin. Now total, in this case, just means added together. So the total of your spins would be the first spin plus a second spin. And so what I've done here, I've just listed the different possible outcomes for each spin. So it could land on a 1, it could land on a 2 here. This third side is also a 2, the fourth side is a 3, and the last side is a 4. And the same possibilities for the second spin, because we're still talking about the same spinner. So this one here, this space, represents if it lands on a 1 first and then a 1 again. Well, the total of that would be 1 plus 1, which would be 2. Or maybe we spin a 2 and then it lands on a 1. 2 plus 1 is 3. And so all we're going to do for all these different spaces is just add up what you get for the first spin to what you'd get for the second spin. 2 plus 1 is 3, 1 plus 3 is 4, and so on and so forth. And so what we're going to do is just add up all these numbers, the numbers above the box to the numbers to the left. So 1 add 2 is 3, and 4, 4 again, 5, 6. 3, 4, 4, 5 and 6. This one, 4, 5, 5, 6 and 7. And the last row, 4 plus 1 is 5, 4 plus 2 is 6. Same again. 4 plus 3 is 7. Finally, 4 plus 4 is 8. And so what we're interested in here is the probability of scoring a total of 4 with 2 spins. And so, how many of these different spaces have got a 4 in them? Well, that's 1 4, 2, 3, 4, 5, 6. Just being careful in case I've missed any. It's easily done. I'm pretty sure I haven't. So, looking there, I can see that there's a total of 6 4s. There's 6 different ways of getting a total of 4. Out of how many different combinations? Well, there's 5 rows and 5 columns, so it's 6 4s out of 25. So there's 25 different combinations, and out of them 25, 6 out of 25 would give you a total of 4. And so the answer for part B would be 6 out of 25. Question 19. We have a diagram showing distances by road between 4 different cities: Newcastle, Liverpool, Hull and Bristol. And so it says that Sam drives from Newcastle to Hull and then from Hull to Bristol. So let's just highlight this on the diagram just to make it clearer. So Newcastle to Hull is this one here, and then Hull to Bristol is straight down here. Tim, though, goes a different way. Tim drives from Newcastle to Liverpool and then he goes from Liverpool to Bristol. And so it says Sam drives 10 more miles than Tim. Work out the distance by road from Liverpool to Bristol. So what I've done here is I've sectioned out this page into 2 different parts. And so for one part, I need to consider Sam. How far Sam travels. Well, Sam goes Newcastle to Hull and then from Hull to Bristol. So Sam travels 145 miles first from Newcastle to Hull, and then after that he travels from Hull to Bristol, which is another 220 miles. So in total 145 plus 220, you should find that that's a total of 5, 6, 3. 365 miles. Whereas if we have a look at what Tim drives, Tim goes from Newcastle to Liverpool, which is 175 miles. And then after that he goes from Liverpool to Bristol. Now, we're not told how far it is from Liverpool to Bristol, and that's what we need to find out. And so what I'm going to do, I'm going to call the distance from Liverpool to Bristol just a letter. I'm going to call it x. So we need to work out what x is. So them 2 distances combined, 175 plus the missing distance, is what Tim travels. So we need to piece these 2 bits of information together now. So if we have a look at these 2 bits of information, for Tim and for Sam, we're told that Sam drives 10 more miles than Tim. And so if this is Sam's distance here, 365, we can say that that's the same as Tim's distance, which is this one here, but 10 more. Sam's distance is the same as Tim's, but 10 miles more. So then we're going to add 10 to this. Now what we can do is treat this as an equation and just neaten it all up. And so this left hand side would stay as 365. This side here, 175 plus 10 is a total of 185 plus x. And so what we need to do is have x on its own. So what we can do is get rid of this 185. As it stands, this 185 is a positive thing. So if we swap the side of it, we'll swap the sign of it. Opposite of positive is minus. And so that tells us that x is going to be 365 take away 185, which we can do. So 5 take 5 is 0. 6 take away 8 we can't do, so we can buy one from the 3, which becomes 2. The one we've borrowed can move on here. Now this becomes 16. 16 take away 8 is 8. 2 take away 1 is 1. And so the distance for x is 180. So the distance by road from Liverpool to Bristol is going to be 180 miles. Part B for question 19. It says here that Rob is going to drive 130 miles from Hull to Liverpool, and there are roadworks for 25 miles of the journey. So he's going to assume his average speed will be 50 miles an hour where there's roadworks, and 70 miles per hour for the rest of the journey. So we need to work out his total journey time. And so here we've got assumptions about speed, we've got miles, which is distance, and we need to work out journey time. And so this question relates to speed, distance and time. So what you might be thinking here is that it'll be a formula triangle, and if you did think that, you'd be right, because this one is a formula triangle, speed, distance, time. And so in this case, what we need to do before we get to the triangle is to think about the information we've been given. So what we've got here is some roadworks. And we're told about the roadworks, there's 25 miles of the roadworks, and the speed will be 50 miles an hour where there are roadworks. And so what I'd suggest you do is to section it out in terms of thinking of a journey as a section with roadworks, and the rest of the journey as the bit where you don't have roadworks. So just think of it as two different parts of information. So we can do roadworks first of all because we've got the information here. We want to work out the journey time. So using this triangle, whatever you want to figure out, you cover up. And so you want to work out the time. So cover up time. Whatever's left tells us what to do. And the position the things are left in tells us what to do with those things. And so if you cover up the time, what's left is d on top, speed on the bottom. So what this means is distance divided by speed. So during the roadworks, 25 miles is the distance, and the speed is 50 miles per hour. Or so he assumes anyway, so the only thing we can do is just assume that his assumptions are valid at this point. Now we can do 25 divided by 50, or we can just leave it as a fraction and try and simplify it down. If you fully simplified this down, we should eventually end up with that 25 out of 50 is the same as a half. Now is it half a minute, half a second? Let's have a look. The units we put in for speed, mph, the h stands for hours. And so if the units going in relate to hours, the units coming out will also relate to hours. And so that's going to be half an hour. So the roadwork section of a journey should take him half an hour. Now let's think about where there aren't any roadworks. We're told that there's 130 miles of a journey and there's roadworks for 25 miles of the journey. So based on that, what we could do is work out how much of a journey isn't going to be roadworks. So 130 miles in total. If 25 of that is roadworks, that means the remaining 105 should be without roadworks. So now we've worked this out, but there's 105 miles expected with no roadworks. We can apply the same formula to the section of the journey which isn't going to be affected by any roadworks. So again, because we're working out the journey time, the time taken will be the distance covered divided by the speed. Now in this case, where there's no roadworks, is going to be 105 miles covered, and the speed of that is going to be 70 miles an hour. So again with this one, we can simplify it down. So taking it step by step, what we can do is think about what we can divide 105 by and divide 70 by. If a number ends in a 5 or a 0, it means you can divide it by 5. And so what we can do is the top and the bottom and divide it by 5. So looking at the bottom, 70 divided by 5. How many 5s fit in 70? 5 into 7 goes once, with 2 left over. And 5s into 20 goes 4 times. And so the bottom number would become 14. And then at the top, 105 divided by 5. Let's think about that one. Can we fit 5 into 1? No, we can't, because 5's too big. And so the remainder for that one is that 1 itself. So that 0 has now become 10. 5 into 10 goes 2 times with nothing left over, and 5 into 5 goes 1 exactly. And so the top number would simplify down to 21. But 21 over 14 again simplifies down because 21 and 14 are both in your 7 times table. And so that means we can divide these both by 7. 21 divided by 7 would be 3. And 14 divided by 7 would be 2. So that's 3 halves, which we could change into a mixed number by seeing how many 2's fit into 3. We can fit 1 2 inside 3 with 1 half left over. So 3 halves is 1 1/2, and again, that's going to be hours. So just combining where we've got roadworks, that's half an hour. With no roadworks, that'll take an hour and a half. So the total time taken is half an hour plus 1 1/2 hours. Well, half plus half is a whole hour, plus an extra whole hour. That'll be a total of 2 hours. So the total journey time expected is going to be 2 hours. Or if you prefer, you can leave it in minutes and say it's 120 minutes. But for this question, I think the answer leads itself more naturally to being in hours. And part C, it says Rob's assumptions about his average speeds are too high. How does this affect his journey time? Well, if his assumptions about his speed are too high, that means in reality he's going to be travelling slower. If he travels slower, his journey will take him longer. And so how does this affect his journey time? It means his journey will take longer. So that's what we need to write down for question 19, something along those lines. Question 20, we have a Venn diagram. Part A is fairly straightforward. It just asks us, what does the number 7 on the Venn diagram represent? Now, the number 7 is the bit of the Venn diagram where the circles overlap. So that 7 is in the circle for geography and the circle for history. And so the Venn diagram is about students that study geography or history. And so because the 7's in both circles, what it represents is, that's the number of students that study both geography and history. Or at least students that say they study both geography and history. I suppose it could be lying, but it'd be a bit of a strange thing to lie about. So anyway, that's just the students that say they'd study both geography and history. Part B, we're given some information and then asked to... Damn software upgrades. Anyway, never mind that. 20 students study geography but not history. 19 students study history. Complete the Venn diagram. So we now need to add this information into the diagram. So what we're told here is, first of all, 20 students study geography but not history. And so those students study geography only and have nothing to do with a history circle. And so those 20 geography but not history, that is the students in the geography circle only. So I'm just trying to colour this in as nicely as I can. Dum da dum dum. Nearly there now. So geography but not history is just that part of the circle, so that's 20 students. Now the 19 students who study history, it doesn't mention if they study geography as well, so that 19 students is going to be for the whole of the history circle. So that means 19 students in total study history. And so that number there represents the total history circle. Bear with me to just colour this in. I've started, so I might as well finish. It's very rare in my adult life I can justify colouring things in, so just let me have my fun. The sad person I am. Okay, so all of this history circle is the people that study, obviously, history. So we've got 7 here in the middle, and so this must be the other 12 people that study history on its own. And so if 7 people study both history and geography, 19 people study history in total, there must be 12 people that study just history. 12 plus 7 gives us 19. Bear in mind though, there were 50 students altogether asked. So how many students do we have so far? We've got 20, 7, and 12. 20 plus 7 plus 12. If you add those numbers up, that comes to 39. But with 50 students altogether, how many students are missing? We can work that out by doing the difference. 1 take away the other. 0 take away 9 we can't do. So if you borrow 1 from the 5, which becomes 4, and the 1 we borrowed, put it here, that 0 is now 10. 10 take away 9 is 1. 4 take away 3 is 1. So that means if 39 students study some combination of geography, history, or both, there's 11 students still left, and those 11 students left must mean they don't study either geography or history. So those 11 students left go outside of the circle here. What goes outside of the circles represents the students that study nothing, which is anything to do with the circles. Question 21, we've got a ratio question relating to a fizzy drink. And so we've got instructions on how to make fruit squash. So it's mixing 2 parts squash with 7 parts lemonade. So I'll do this the standard way first. So squash on one side, lemonade on the other. 2 parts squash to 7 parts lemonade. 2 plus 7 means there's 9 parts altogether. I'll just do that line sort of underneath. Two lots of squash, 7 parts lemonade, as I say, gives us 9 parts in total. And those 9 parts mixed together needs to give us 450 mils of fizzy juice in total. So if 9 parts equals 450, we can work out what 1 part's worth by just dividing by 9. If we divide 9 by 9, we get just 1 part. So if we divide this side by 9, to keep the proportion correct, we need to divide this side by 9 as well. Well, 45 divided by 9 is 5. Pop a 0 at the end. We'd have 50. And so each part represents 50. This fruit squash, we have 2 parts, and so 2 times 50 gives us 100 mils. And so we'd mix 100 mils of fruit squash to make 450 mils of juice altogether. Now, the more I've done ratios, the more I realise that doing this method can lead to some problems. Not always, but just sometimes. And so a table method is often used, and is often used by myself. So we can section it out into parts of different things and the total. In this case, the total represents fizzy juice because we mix the squash and the lemonade combined to make the juice. So first of all, we're told, this is just a different method, by the way. So we've got the answer now, I'm just showing you a different method. So 2 parts squash, 7 parts lemonade. That'd be 9 parts total using this method. Now we want to have 450 mils of fizzy juice. And so we want to build up the fizzy juice from 9 as it is now up to 450 mils. That's what we want. And so we can get from 9 to 45, for example, by multiplying 9 by 5. But if we multiply the 9 by 5, we need to do the same to the other parts as well to keep the balance correct. And so 2 times 5 is 10, 7 times 5 is 35, and then to go from 45 to 450, we can then multiply by 10. But like I mentioned before, if we multiply one side by 10, we need to do the same to the other bits as well. So 10 times 10 is 100, 35 times 10 is 350. And so what we're interested in is fruit squash, and so how much fruit squash is needed? Be 100 millilitres. Part B, similar question but slightly different. This time, Tom's got some squash, 80 mils, and he's got 200 mils of lemonade. We've got to work out the maximum amount of fizzy juice he can make. So this is a part where this table method sort of comes into its own a bit more. And so if we had 2 parts of squash, we'd use 7 lots of lemonade, which should give us 9 lots of fizzy juice. Now, one of these ingredients will run out first. So it's a case of seeing what's going to run out first. As soon as one of the ingredients run out, we know that we've made as much fizzy juice as we possibly can. So 2 is loads off 80. 7 is loads off 210, so we can make these numbers quite a bit bigger. What I'd suggest we could do
first off, is just multiply all these figures by 10. It's up to you how you build it up, but no matter how you build it up, you want to aim for these figures and seeing if squash hits 80 first, or if lemonade hits 210 first. So let's start, for example, by multiplying all these figures by 10. 2 times 10 would be 20 mils, 7 times 10 would be 70 mils, 9 times 10 would be 90 mils. What we could do, we could do the same again. We could take these numbers here and just double them if we wanted. So if we double these, just for example, just double all the values. 20 times 2 is 40. 70 times 2 is 140. 90 times 2 is 180. But have a look here. So far, we've got 40 mils of squash. So we've only used half of the squash. But for lemonade, we've only got 210 mils of lemonade. So we've used more than half the lemonade. And so lemonade looks like it's going to run out first. And so if we've got 210 mils of lemonade, if you spot here, we can make 210 exactly by adding these two figures together. And so what we could do is just total up the last two columns. So if we add, sorry, not columns, rows. If we add this row to that row, 20 plus 40 would be 60 mils. 70 plus 140 is 210 mils of lemonade. So now all the lemonade's gone. So this is the maximum we can make. 60 mils of squash, 210 mils of lemonade. That gives a total of 270 mils of fruit juice. So that's the maximum amount of fruit juice we can make. 270. That's as much as we can make before the lemonade runs out. Question 22. We've got 4 identical circles that just fit inside a square, as in this diagram. We need to work out the area of the shaded region. Give your answer in terms of pi. Well, first of all, let's have a look at the most obvious shape here, which is the square itself. I'm hoping you know, in fact I'm sure you will know, that for a square, the length of a square will always be the same as the width of a square. So this square we're told is 12 long. That means it will also be 12 wide. And so for the full square, we can work this out easily enough by just doing the length of it times the width. Area of the square will be 12 times 12, literally 12 squared. You should really know 12 squared without too much difficulty, but if not, you could do 12 times 10 and then another two 12s on top. But 12 times 12 you should find is 144 cm squared, and so the whole shape is 144. But obviously we've got these circles as well to deal with, and so if we just have a look at one of the circles, we've got 2 circles going across. Now the full length is 12, that means half of the length of the square will be 6. So this circle here, for example, as all of them, because of 4 identical circles, the length of this circle will be 6. So from end to end, that circle measures 6 centimetres. Now from end to end, the length of a circle from one end to the other is called the diameter. So for the circles, the diameter is 6 centimetres. So for radius, you should know that the radius is only halfway. The radius is from the middle going to the outside. So for these circles, the radius is half of 6, which is 3 centimetres. So for one circle, you need to remember the formula for area of a circle. The area of a circle is pi r squared. If I remember the formula for a circle is that you need to know that chicken pie is delicious and apple pies are too. If you're vegetarian, more credit to you. We can substitute this for a cherry pie or a chocolate pie if you like to eat lots of chocolate. So chicken pie is delicious, apple pie is the dessert, so A comes second, apple pies are too. Or you can just remember, like Mr. Lawrence drilled me with information that area is pi r squared when I was about 14 years old. Anyway, remember it, the area of a circle is pi r squared. Area is measured in squared units, so again that's another tip that you should know, that the area formula is one involving the squaring. Square units, it involves the square. Just makes it slightly easier to remember. Anyway, enough of me talking. In this case, the radius of a circle, we've just said, is 3 centimetres. So pi r squared means pi multiplied by 3 squared. 3 squared is 9. So it's pi times 9. But because we're leaving our answer in terms of pi, what this means is we're going to leave pi in the question. It means we leave a pi symbol in there. We don't actually use a numerical value for pi, we leave a pi symbol in the working and the answer. So you don't actually give a numerical answer for pi. That's what in terms of pi means. Pi times 9 is just 9 pi. So for one circle the area is 9 pi, but how many circles do we have? We've got 4. So for all 4 circles, the area will be 9 pi times 4, which will be 36 pi. Now we're nearly there. The area of the shaded region that's just going to be the area of the square with these circles sort of cut away. So it's the area of the square minus the area of those 4 circles. Which we can say is 144 minus 36 pi. So that's the area in terms of pi, that many square centimetres. Question 23. You have a bag, 2 bags in fact, bag A and bag B. And so Joe says it's more likely that a blue ball is chosen from bag A than bag B because there are more blue balls in bag A. Is she correct? Show your working. And so let's just consider these bags separately. So in bag A, it mentions about blue balls here. So in bag A, there's 10 blue balls and 20 red. So in bag A, there's 30 balls altogether. So in bag A, 10 out of 30 balls are blue. Now as a fraction, That means 10 out of 30 of the balls are blue. So that's the relative frequency, as it's called, of how many blue balls there is. And that's the best probability, the best estimate of probability of picking a blue ball. If 10 out of 30 of the balls are blue, then the chance of picking a blue ball from bag A would be 10 out of 30. And that fraction will simplify down. We can divide both 10 and 30 by 10, which gives us 1/3. So in bag A, you've got 10 out of 30, which are blue, and 10 out of 30 gives you an estimated probability of 1/3. Let's compare that to bag B. Now bag B doesn't have as many blue balls, like the question mentions. In fact, bag B just has 8. But bag B has 8 blue balls and 12 red. 8 plus 12 means bag B has got a total of 20 balls. And of those 20 balls, 8 out of 20 are blue. So as a fraction, 8 out of 20 could be written like this, which will simplify down. We can half both numbers, which gets 4 out of 10, which then goes down to 2/5. And so which is a bigger fraction, 1/3 or 2/5? One thing you could do is convert them into percentages by multiplying these fractions of by 100. Effectively find this fraction of 100 for each one. 1/3 of 100 would be roughly 33%. 2/5 as a percentage, 2/5 of 100 would be 40%. So bag B, you've got more chance of picking a blue ball from bag B because 40% is a bigger percentage chance than 33%. I'll try to show you, if I can, a different way using the idea of drawings, which isn't as scientific, but it should do the trick if you're really stuck. And so 1/3, what we could do is picture 1/3 as a diagram. And just think, just how big does 1/3 look? 1/3 is when you've got 3 different sections and you want one of them. So in this case, 1/3 would be the size of one of these. It depends on you drawing it quite accurately as well. You can't always do this. For example, for awkward fractions, I'd never advise doing this. Numerical methods are normally always better. Now, in terms of fifths, if you split something into fifths, what that means is it's divided into 5 different parts. So if you try and divide this equally into 5, it's a bit harder to do because it's a slightly more complex fraction. Not much, but it is a bit. That's not too bad. It's not perfect, but I'll take that. So, if you wanted 2/5, then 2/5 we could show by colouring in 2 pieces out of 5. So think of it in terms of which is the bigger fraction, if you like. You could compare fractions by getting the denominators the same, or think of it in this way. Which slice is bigger? Quite similar, but hopefully, just hopefully, you should be able to see this is a slightly bit bigger than that one. Slightly. If I drew it accurately, it'd be clearly bigger, but this one over here is slightly bigger than this one here. That's why I'd suggest doing a numerical method if you can, because there's less confusion and less chance of getting it wrong. But if you had to, you could try this and just seeing which one is the bigger slice. At any rate, going back to your initial question, is she correct? Well, no, she's not correct, because you're more likely to pick a blue ball from bag B, as these diagrams hopefully show, but definitely these percentages would show. More likely she picks a blue ball from bag B. And that's question 23 completed. Question 24, we've got some numbers and we need to put them in order of size. And so knowledge of standard form would be really helpful here. And so what I'm going to do, I'm going to just take the numbers one by one and just show you how to put them in order of size and write them as an ordinary number. And so the first one is 6.15 multiplied by 10 to the power 4. Now the power of 10 tells us how many places this decimal is going to move. If it's a positive power, like it is here, the decimal will jump to the right. A negative power means the decimal jumps to the left. And so what's going to happen here is the decimal is going to move 4 places to the right hand side, because the power of 10 is 4 for this number. So if the decimal was here, it's going to end up being 1, 2, 3, 4 places to the right. So it jumps over the 1, jumps over 5, jumps over nothing. Nothing in maths is a 0. Jumps over nothing again. Nothing in maths is a 0. So you can put the dot there if you want to, and a 0 there if you want to. But effectively that's going to be 61,500. This one here, 6.2 multiplied by 10 to the power 3. It's the same idea, but only now the dot's going to jump only 3 numbers to the right. And so 1, 2, 3 places, jumps over for 2, over for 0, over for 0 and lands here. And so this number is 6,200. So it becomes 6,200. The first number I said was 61,500. And finally, this number, 61.6 multiplied by 10 cubed. So again, in the same way, we look at the power of 10. This power of 10 is 3, and so the decimal was here. It's going to move 3 places to the right. So 1, 2, 3. 1, 2, 3. So the decimal will jump over the 6, over 0, over 0, and will land here. So we've got 61,600. And so compare the 4 numbers. Not forgetting, of course, one we've not changed. 61,600 is bigger than them all. So the one we need to circle is the one which is 61,600, which is this n number. So make it clear that we're circling this one. Question 25. Jack works out the answer to this. He says the answer is negative. Is he correct? You must show you're working. Look, it's only 2 marks. You are not going to be expected without a calculator to do the square root of 98.5. I, hopefully, would never be asked to do that because I'd struggle as well. The idea here is to use estimations. And so the square root of 98.5, I've no idea what it is really. All I know is it'll be 9 point something. And the reason I know that is because the square root of 95 we can change that. We can round it off. 98.5 is roughly 100, so we can round 98.5 to 100. So 98.5 is approximately the same as the square root of 100. And now we do know the square root of 100. What number multiplied by itself gives us 100? The answer to that is 10. We're not really concerned with the exact value. All we're concerned of is if it's positive or negative. And so if I just get this here, move it down to give us more space, this is roughly equal to the square root of 100 minus 12.1 divided by minus 0.8. So we're changing just this thing here to the square root of 100, and we said the square root of 100 is 10 because it is, and so the square root of 98.5 won't be far off 10. And so if we just say the square root of 100 is 10, because it is, the top number is going to be roughly 10 minus 12.1 divided by minus 0.8. So again, don't get caught up with trying to work out an exact value. That's a trap you could possibly fall into. Just think about if this top thing is going to be positive or negative. If you do 10, take away 12.1, the answer is going to be minus 2.1. And so you know the top number is going to be negative. So you're going to have a negative value on the top of your fraction. And minus 0.8 is obviously a negative value. And a negative thing divided by a negative thing gives us a positive value. Negative divided by a negative gives us a positive value. In the same way that a negative number multiplied by a negative number gives us a positive. When you're multiplying or dividing numbers, if the signs of the numbers is the same, the answer ends up positive. If the signs of the two things are different, that's when it ends up negative. And so it's shown here that this calculation should give a positive value. Jack says the answer is going to be negative. Is he correct? The answer is therefore no, he's not correct. It won't be negative, it'll be positive. To answer the question, you need to say no, because it's a yes or no question ultimately. Negative divided by negative will be a positive value. So is he correct? Definitely conclude by saying clearly no, he's not correct. Question 26. A ball is dropped from a height of 50 meters. After each bounce, the ball reaches 20% of its previous height. How high does it reach after the first bounce? So what we can do first of all is just consider it as the first bounce. So after the first bounce, it just gets 20% of its previous height. So what we need to do here is work out 20% of the height it was dropped from. 20% of 50. %20 of 50, well, 100% of 50. 100% of any number is the number itself. If 100% of 50 is 50, then 10% is the same as dividing by 10, or in this case knocking a 0 off each side because both numbers are whole. 10% would be 5. So if I double both sides, multiply both sides by 2, that tells us that 20% would be 5 times 2, which should be 10 metres. 20% of 50 would be 10 metres. Because each time we're going to be finding 20% of the previous height. And so for this question here, the previous height was 50. And we're always finding 20% of it. So for the second bounce, just be thinking, how high did it bounce up after the first bounce? So it got to 10 metres. So just rereading the question, it's now going to reach 20% of the previous height. So after the first bounce, that'll be 20% of 10. Because for the second bounce, the previous height was the first bounce, which was 10. So the same as before, we worked out the 20% of 50. Over here, we can just work out the same way. Whoops. We can work out 20% of 10. So again, 100% of any number is the number itself, as I said before. So 100% of 100% of 10, my apologies, is 10. Knock a 0 off. 10% would be 1. So to get 20%, we can just multiply both sides by 2. So times 10% by 2 to get 20%, and times 1 by 2 as well. So 20% would be 2. And so that's the question done, really. So after the second bounce, we'll get to 2 metres. So the final answer is 2 metres. Question 27, it says we need to use a ruler and a pair of compasses in this question, and we need to construct the perpendicular bisector of the line from A to B. So doing as the question says, we need to get the compass out, and we put the compass at the end of one bit of a line, and we make sure the width of the compass is over half the length of AB. Doesn't matter exactly how long it is, but as a rule of thumb, try and make it about 2/3 or 3/4 the length of the line. As long as it's more than half, that's the main thing. You don't have to be exactly 3/4 or 4/5, or don't panic over it. Just make sure it's definitely over half. So 3/4 will do. Then once it's halfway, get your compass. Just give myself a bit more space down here, and you do a big sweeping semicircle bit from one side all the way to the other side of the line. Then what we do is do exactly the same at the other end of the line, and don't alter the width of your compass. Keep the width of your compass exactly the same, and do the same from this end as well. And what you should get is 2 semicircular curves, roughly semicircular anyway, which cross over above and below the line AB. And where they cross over is where you're going to draw a line through them. So what we're going to do is draw a line through this point, which goes up through this point as well that it crosses. So the perpendicular bisector of AB would look something like this. So just get it all in view. Put your compass on one end, turn it, compass on the other end, same distance, turn it, straight line between where they cross over, and that's your perpendicular bisector all done. And the last question now, question 28, is about a circle and a square. This question's quite nice in terms of it says what you need to do. We're going to use Pythagoras' theorem to show that the square will fit inside the circle without touching the edge of the circle. Now imagine the biggest possible square that had almost touched the sides, but wouldn't quite. So imagine putting a square inside the circle and the square getting bigger and bigger until it's nearly touching the sides. To try and picture it, I've got a drawing for you here. So what would happen is that square gets so big, it eventually touch the sides when the diagonal of the square is the same as the diameter of the circle. So from end to end, that's the diameter. And so if the diagonal of the square gets to 10, that's when it'd be touching the sides of the circle, which it's not allowed to do. And so what we need to prove is that the diagonal of the square, this bit here, we need to prove that's less than 10. If that's less than 10, these two corners won't touch and the circle won't be touched by the square's corners. And so if I just draw this diagonal in here, I'll just set as a mission. So the mission is, I'm pointing to that line, I'm going to say, we need to prove this is less than 10 centimeters. That's what we need to do. So if I just consider this a triangle, well, it is a triangle obviously, but just looking at this bottom triangle. Now the shape I'm making this triangle from is a square. So if the sides of it are 6, so if this bit here is 6, that means the top bit of it will also be 6 as well. So Pythagoras' theorem relates to all three sides of a square. So if I call this longest side, the longest side of a square is called the hypotenuse. So I'm just going to call it h for hypotenuse. Now Pythagoras' theorem says that the hypotenuse squared is the same as one short side squared plus the other short side squared. But because both sides are the same, that means 6 squared plus 6 squared. Because both sides are 6. Now 6 squared means 6 times 6, which is 36. So that'll be 36 as well. And 36 plus 36 equals 72. And you should know that the final step for Pythagoras is to take the square root of something. So to find the length of that, you'd have to do the square root of 72. Now I'm not expecting that you know what the square root of 72 is, nor is the examiner expecting you know. All the examiner is expecting you to know is that this is going to be less than 10. And the reason you should know that's less than 10 is because the square root of 100 is 10 centimeters. So as long as we're square rooting a number smaller than 100, the answer will be smaller than 10. So because the diagonal of the square is less than 10, it won't touch the circle. Because the square's diagonal so back where we're writing, because the square's diagonal is less than 10, the square won't touch the edge of a circle, or words along those lines. And that's question 28 completed, and also the whole paper completed. Thanks for listening to at least part of that. Hope you found some of it useful. Keep working, keep attending your lessons, keep revising, and just remember, never give up. Keep working hard. Okay, thanks so much for listening. Leave a comment if you'd like and subscribe, and I'll see you again soon.